launcher. Garage in the building. Your boy Frosso Fries over here. Let's just get greasy. Let's get it. Let's go. Welcome back to part 2 of the Trackhawk build. Thanks so much for joining. So just get right into it. I decided to shoot a time lapse off the engine disassembly. I didn't want to bore you guys too much, so right off the top, removing the pistons real quick. Got all the connecting rods out, kind of squared those up and left them respectively. Now removing the mains, getting those bolts up, get the side bolts up from the main journals. A little trick, you can just use the original bolts, just hold them against the main journal cap so you can just wiggle them out. So crankshaft is gone, getting out the main bearings, rear main seal is gone. Yeah, just try to be uniform and keep everything together. Right now I'm removing the jets for the cylinders, for the oil squirters. Those got to be removed as well, because when you're doing the machining on the block, you just got to remove all that stuff. You don't want to contaminate it. Get the mounts out. Mounts are out of the way. Now we're on the top of the block, getting rid of the lifters and the lifter trays, because you want to gain access to removing the camshaft, and you won't be able to remove the camshaft unless you remove the lifters slash rollers and the tray assembly as a unit. So now removing the thrust plate from the front of the timing cover, getting that gone underneath the timing components there. Now we're just going to slide in the factory bolt and just, you know, take our time and kind of wiggle out the cam, trying not to damage any of the bearings inside. Okay, there you have it. It is completely disassembled. Everything is removed. Now, next thing is to take it to the machine shop. So, to the machine shop we go. I got all the pistons already, all the rotating assembly. I got the entire rotating assembly. I got a forged crank, courtesy of MMX. Got some pistons, courtesy of MMX. I'm gonna be doing an unboxing of those products soon, but for now, I'm gonna run off, take the machine, take the block to the machine shop. I'm gonna take a couple pistons, the ARPs and the crank, because we're gonna be doing a lot of extensive work on the block itself to make sure that it is A-OK and in tip-top shape to run as much boost that we can possibly stuff in this Trackhawk. So yeah, so when it comes back, I'm gonna give you a little detail of what got done to it and how much it roughly costs, and you know, get it going for assembly. So thanks for tuning in, and stay tuned for the rebuild. Don't want to miss it. You want to pay close attention to the details and the information that I have to offer. It's a lot of formulas that I use, and this method I use quite a bit on these Gen 3s. This formula works. I've made tons of power using this formula, so check it out. We're here with the Trackhawk. I got it finished already. We're done. We just made 1100. Now I'm playing. Yo, check it out though. I just got all the block and stuff back from the shop. It's right here. I'm gonna start building it and assembling it. We got some cool parts to show you from a lot of our sponsors and a lot of product manufacturers. So I want to shout out MMX, Dave Weber, Byron, all those guys over there at Modern Muscle Extreme. Thanks for putting together some real good stuff, some killer power pack products. So we're gonna show you how I utilize those and assemble those. Working with a lot of guys from BTR, Texas Speed, you know what I mean, LNR. So we want to shout out all those guys real quick. So without further ado, let's just start chopping it up and show you how to put this thing together. Let's go. I've got the block on the stand. We're gonna be building the short block. When I got done to it on this shop, we got the deck honed. We actually got it laser cut because I like the laser precision cuts. It's better for my peace of mind, so I like that. We got alignment honed on the cradle, which means that we cut the cradle perfectly straight where the crankshaft sits down. We'll get into that later on in the video. We did a full 100% blueprint on this block. So this block is race spec'd out and ready RTR to go. Let's just come over to the bench real quick, and then I'm gonna show you how to do it. So here you got your piston compression ring. I like to start out with the second ring and then work my way upwards. So usually I do the second ring, and then I do the top ring. And then first what I do, I take the piston oil ring and I put them on. I also phase them and clock them too. So I got the ring rails right here, and then I got the expander, which is the little spiral ring sitting in the middle. And then you want to put the gap of the spiral ring to the exhaust port, relief port, to the middle of the piston skirt. And then you can start off with your bottom ring rail, and you put that gap to the left of the exhaust relief port. That's how I like to phase them. And then the top of the ring rail to the other end of the piston skirt as far as the relief port side. So that's how you do that. Once again, I'm going to run through it so you don't have any confusion. You want to face your piston upwards. You got your exhaust relief pocket right here for your exhaust relief valve. And then you got your exhaust. This is your intake, sorry. And that's your exhaust relief valve. So intake relief valve, exhaust relief valve. You flip your piston upright. Your oil expander ring goes on first. And make sure the gaps are pointed downwards. So the two pieces that look like an M, make sure they're pointed downwards. And then the oil ring rail, the expander rail, make sure the bottom piece or the bottom portion is faced towards the left of the skirt. Once again on the exhaust port, and then top rail on the exhaust port on the right side. So that's how you properly gap them and phase them. That's how you orient the rings. So I'm gonna grab my second compression ring, and what I'm trying to do is achieve a target gap between these two spaces. This is how it looks when it's in the bore. So out the factory from the box, they're not ready for installation. Do not build your engine without measuring the end gaps on the compression rings. You will break the engine. You will ruin your totally expensive build. I promise you. So what you want to do is take it over to the bore. Then you're going to make sure you clean the bore and make sure what you're filing them to, each bore is respective. So you can't file this for this bore and put it into that bore. It's just not going to work. Just make sure you keep everything uniform. You want to treat it like a race engine because the parts are expensive. So what I'm going to do, I already cleaned the bore already. I'm going to just spray some WD right there just to lube it. And then I'm going to put the compression ring. Once again, this is your second compression ring. How you know it's the second compression ring is because it's got the step down right here in the ring. It's not shiny on the edge. So this is your Napier ring for the scraping. So you just set it down in there like that. And if you zoom in with the camera, you can see that there is no gap there. You look right here. There is no gap. You cannot install that. What will happen is the chamber will get hot. These rings need to expand. And if there's no gap, they're just going to butt. And then they're going to lift and crack the piston. Ruin your totally expensive build once again. So be mindful. So we're going to take it over to the filer quick. I don't want to bore you guys too much. So you want to set it on the filer just like this. You want to zoom in with the camera. And make sure the ring is facing upwards. This is how it signifies that the ring is upwards with the M sign for Mal. That's the brand. So you keep that upwards. And you can just file one side and make sure you keep everything straight. So just take your time, just like that. So what you're trying to do is achieve a gap in the end ring, in the end gap. So you just keep filing. You don't file too much because you don't want to take off too much of the material. Because when you take it off, you can't put it back. So I'm going to file a little bit, what I know. and you put them together, check for straightness. The idea is you don't want to see any light going through that line that you have them meeting. If you can see any light going through there, that means you got them offset, and that's not going to work well. You're going to have a little bit of blow by, so you want to keep them uniform, perfectly straight. So then I'll grab my filer. And then I'll just deburr the edges. Just you don't want to scrape the walls of the engine, that cylinder, so just take off the little burrs that we created from filing. You check the end gap again. Look straight to me. Make sure you clean. I can't stress that enough. You gotta treat it like a race engine. You don't want any metal parts going through your engine. That's bad. So now you take it back over to the bore. And now what we're trying to target here. See, now we got a gap going on right there. We've got a gap. So what we're gonna do is trying to get the ring square in the bore. Trying to get the ring square in the bore like that. I like to use the piston just to get it like at least an inch or so down, so you know it's perfectly flush. Because usually when it comes up to the tight edge, that's where it gets really tight, and the compression ring wants to, you know, collapse on itself. So now you can see that we have a somewhat of a gap in there as compared to before. We didn't have a gap, but we still can't fit this end of the feeler gauge through. This end is 28 thousandths of an inch. That's the target gap that you want between this compression ring. That's usually what I do for boosted applications. If it's supercharged, turbocharged, forced induction, I use 28 thousandths on the Gen 3s, and then on other vehicles you want to use those applications respectively. But anyway, this is the tedious procedure. Yes, I know it sucks. You got to do it. If you want your engine to live for a long time, you got to take the cautions. You got to do your measurements. Don't trust the machine shop when it comes from the machine shop. You don't know what clearances they put in, and you know it's always just critical for an engine builder to just take note of what you're doing and take your time. All right. So what I'm gonna do, I'm gonna continue to file until I can get to 28 thousandths of an inch. I'm not gonna bore you on camera with all the filing. I kind of just speed through all that on a time lapse, and then when I get to 28 thousandths of an inch, then I'm gonna show you what that should look like. What feeder gauge should be able to go through there. All right, let's go. Okay, so we just put some more gap in there, so we're just gonna check to make sure it's pretty straight right here, so you can see, get it straight. I don't have no light through there, no light, so that's the aim. You want to kind of get the gap straight. So we're gonna take it over to the board and measure how much gap we got between the ends of the compression ring while it's sitting in the bore, about down an inch. We're back on the bench. Now we're gonna take off a little bit more material, trying to keep a slow pace so we can keep a straight line on the opposite end. Check in periodically, you know, to make sure that everything is nice and straight. No light. I can't see no light through there, so I'll just continue. Just take it nice and easy. Make sure you keep it straight. It does take some skill, but with practice, I don't see it being that difficult. They also have different styles of compression ring filing tools. They have electrical ones. I personally don't like the electrical ones because you run the risk of taking off too much material than you actually want to. So I rather this method. At least you can gauge it up and keep track of what you're doing. So now I'm gonna deburr it just like this. I'm gonna take a file. I'm just gonna lightly scrape the edge just to take off the burr we just created. Just like that, and feel my fingertips. Make sure there's no rough edges. Just like that. Don't be shy. Not gonna break it, but don't go full Hulk on it, because you will mess up this expensive set. And the beauty about doing it this method is that you don't have to ever ruin this edge. Though you could file them both at the same time, like squeezing them together, filing them both at the same time. You could do that, nothing wrong with that. But this way, you know, you can maintain the straight edge, and that's actually what we're trying to maintain. A straight edge between where there's no light present or visible through the compression ring. So at this point, we're going to take it back over to the bore, and then we're going to try to see if we can fit 28 thousandths of an inch through there. It gets tedious, but this is the procedure. So back over to the bore. So we've got our target end gap achieved here. I'm gonna zoom in on that for you. Then I'm gonna try to stick this 28 thousandths of an inch in there between that gap, and just like that. That's what you want. You want it right between that gap. You can see that. See the gap? You want that to be able to slide right through that with the least resistance. So that's how you achieve your target end gap on your cylinder. You just have to keep filing, and just take your time filing it. You know, you don't want to remove too much material too fast, because you can't put it back if you remove too much, and then obviously you're gonna have blow by when you assemble the engine. So that's how you do that. We're finished with the second ring, the Napier ring, so I'm gonna move on to the top ring, and then I'm gonna show you guys once again how to clock and gap them and phase them on the piston. Okay, so we're gonna move through to filing the other one, but I just want to show you something here. I want you to take note. You can see the edge of this compression ring, how it's got like a line in it. That's actually a step down. This compression ring that's got the line in it right here on the edge, this is the compression ring that's your second compression ring. This is the Napier ring. Do not mix them up. If you put this at the top, you're gonna have problems, all right? This one, this is how you locate the top. It has the M right here for mall. I'm gonna zoom in on that so you can see it. So you see that M right there. That's how you know it's the top. This one sits like that. I'm gonna flip it over. You can see the step down that I'm talking about, this little ridge here. This acts as an extra scraper pretty much in the cylinder wall when everything is being doing movement. This actually scrapes the cylinder wall from oil, cleans the cylinder wall, you know what I mean? So do not mix them up. This is the second ring, this is the Napier ring. Do not mix them up. So here's the top ring. You can tell it's shinier than the second compression ring. Here's the second compression ring. There's no shine on the edge. Top ring, shiny. Second compression ring, not shiny. Second compression ring has the ridge. Top ring does not. So I'm just gonna start filing this one. This one is pretty much the same procedure as you would the second ring. And so what I'm attempting to do here is pretty much try to file one side. You could file them both like that if you wanted to. I've done it like that before, but I find this way right here, just file one side at a time to be better, because then you get to maintain a straight edge on the other side. And you can use it as a reference as far as making sure that the edges of the end gaps are straight. So I'm just gonna file this on a time lapse, and that way I don't bore you guys too much. And then I'm gonna put it on the piston. So we're back on the bore, and I'm gonna just try to get the ring down in there. Don't get it too far, just about an inch. I like to use the piston for that bore. I mean, they make a squaring tool for this, a compression ring squaring tool, but this is an old school method that I like to use. Just be careful not to nick the piston or the cylinder wall when you're doing this way. That way you don't damage anything. So now what we're gonna do is try to get some kind of measurement between here. Zoom in good for you here so you can get that end gap. Put it in the center. Good. Alright, so what we're trying to do is get 28 thousandths of an inch through there. Once again, there's a 28 thousandths right there. We're trying to fit this through here. So, and not quite, it's pretty tight. So that just means that we've got to file some more. So let's back over to the filer where we shall grind off a little bit more material and then come back to the board. So as you file, periodically check for straightness between the two ends by putting them together, just like that. Hey, shoot the video, get out of here. Just like that. And you can see that little light. You see that little light? So that means that there's a taper. So now you want to get this taper out. So this is a classic example of why you don't want to go too fast, is then you'll end up taking off too much material. And then if you take off too much material, the piston ring is junk. So just take note. See that little taper at the bottom right there? We don't want that. So I'm just gonna continue trying to remove that taper. Just a little bit at a time. There we go. I can get it. Straight there. There you go. So notice how you can't see through it. That's because the taper is gone. See that? So that's what you want. So we're gonna take it back over the board and measure. Okay, now I'm gonna try to get the measurement again. I think this time we should be good. This time we should be good. Let's square it up right here. Let's see here. And there we go. We've got 28 thousandths of an inch right there. I'll zoom in on it for you.
Well, look at that. Did this one? That
Oops.
that one. I'm a tall, Dan.
Yes. See? That's good there. See if I can get a good angle. Angle's not working for me here.
Daddy, let's hold that.
Look.
Daddy, that fits that one.
Right in there. So that's a good 28.
Daddy, that fits it.
What?
That fits.
Alright. So piston compression ring orientation is what's going on here. So I'm gonna zoom in with the camera a little bit just to get you guys a little more inward there. There we go, that works. Do you see this little gap here? Get me a little pointer so you guys can see what's going on there. Okay, you see this little gap here? That gap there? That's your oil ring expander. This wavy ring, That's your oil expander ring, okay? You notice how the gaps are pointed? The gaps are pointed downwards. So that's what you want to do. You want to make sure that the gaps of your expander ring, your oil ring expander, is facing downward on the piston. And this is located at the exhaust valve relief port, okay? I like to number my piston and put an arrow for my direction of the piston for each piston that I put in at each bore, so that way you keep everything uniformed and you keep everything nice and neat. The next ring that you're going to put on is your bottom ring rail, which is the thin ring. The gaps through here should measure about 0.015, that's 15 thousandths of an inch. From the factory or from the manufacturer, they actually do come pre-file fit, but it's a good practice to check them. Here you can see that's the gap there, right there. So this is where I orient my gaps. I put them at the each corner, each edge of the piston skirt, also on the exhaust relief pocket side of the piston, and so that creates a uniformity, and this is how you orient those rings. The next ring that you're gonna put on is the top ring rail, and this is it right here going all across, and then you're gonna center the gap for that on the opposite end of the piston skirt, and that's just on the exhaust relief port side. So for your oil ring, these three compression rings, they make up your oil ring. This is how you orient them, and that's how you install them. So don't forget, make sure the ends are pointing down, make sure they're not butting, make sure they're nice and in line. Make sure you got your end gap over here. You start with your bottom ring rail first, after your expander rail, and then you work your way to the top ring rail and install that there. Now, I'm going to show you the technique that I use to install the rings. So right here, we've got our pre-filed rings that we just got done filing. This is your number 1 ring. You can tell by the shiny edge. And this one is your number 2 ring. You can tell by the Napier edge. You can see that. I'll just take that away. Take that away so you can focus. Well, there you go. That little ridge there. That's how you know. Anyway, you're gonna start with this one. So what you're gonna do, I'm gonna zoom out quick a little bit. What you're gonna do is 180 the piston, right? Now you're gonna be looking at your intake valve relief port. You're gonna start with your second compression ring, which is this one here. You're gonna make sure that your MAL logo right here is facing to the top. And what you want to do is just set it in the groove just like this. It goes in the bottom groove. I'm going to set my gap right here to line up with this side of the piston skirt on the intake relief port side. So I'm just going to hold it with my finger, hold the gap just like that. Then I'm just going to spiral it around just like that. Now, you could use a separator tool or a piston ring expander tool. I don't like to use those because once again you run the risk of breaking your expensive piston set, and if you do that you got to get another custom set. That's just how it is. I like to spin it just to make sure that it moves freely within the groove, and that's also a good way to test if there's any burrs on the edges of the compression ring, and it turns freely, so that's good for me. I'm going to locate my gap right here. Secondly, I'm going to turn the piston over here. I'm going to come in with my top ring, make sure the MAL sign is at the top, and I'm going to locate the gap over here on the top portion of the piston, just like that. I'm going to hold it with my finger, just like that. I'm just going to spiral it around nice and easy. Try not to force it. You don't want to do that. Just like that. Make sure it sits nice and easy. You don't have to force it. It will just walk its way over there. Just like that. Scratch the piston. Boom. There you have it. Make sure it moves freely, just like the second one. If it doesn't, then you know you have burrs. You're gonna have to take care of that. So here we go, our gaps right there on our second ring, and on our top ring, our gaps over here. So intake side, number 1 compression ring, this side of the piston skirt. Let me zoom in a little bit for you. Just a little bit. There we go. Number 1 ring, intake side, this corner of the piston skirt. Number 2 compression ring, intake side on this edge of the piston skirt. 180 the piston. Zoom in there. Bottom expander the gap. Exhaust side, it's on this side of the skirt. Top rail, exhaust side, opposite end of the skirt. Expander in the middle. So this is the proper way to orient the piston compression rings, and that's how you gap them. So this piston is now ready for installation. Right after I put the bearings in, clean the Conrod journal face, and get it ready. So I'm gonna put these aside, then I'll move to getting a nice little blueprint on the block. I'm gonna show you guys how to put in the oil galleys and stuff like that. Get you up for here. Yeah, I'm gonna show you guys how to put in the oil galleys, and because this one's missing the oil galleys and the camshaft core plug right here in the back. So I'm gonna show you guys how to install that, the oil galley plugs in the back, and then I'm gonna flip it around, install the oil jets, and then